In this episode of Finogric Machining, we are going to make two gears and one bronze bushing. And then we are going to shrink fit all these three together. Yeah, so let's start. Starting with the bigger gear. And first we need to put the dial indicator there in order to get a 70 millimeter piece of round stock about in the center of this 4-jaw chuck. It should be quite center because we only have 2 millimeters spare material in the diameter. Next we will face this one, and here I'm just dealing with the highest spots by manually feeding, and after it is about level, I will do the power feed to make the final finish. Filing off the sharp corner not to lacerate myself with this one. This region is now turned down to 24 millimeters. There will be a smaller gear with interference fit over this region. Interference fit with some torque requires quite good surface finish to be able to cope with that torque. So therefore higher speed and very low cut. Final cut. This will bring the dimension exactly to 24 millimeters. The smaller gear will have a little bit smaller hole in it. Now facing the backside, well, it looks better and is easier to measure. Well, I already drilled a 4 mm pilot hole here. Now drilling through with this 17 mm drill. It doesn't matter if this is a little bit on the side or asymmetric or whatever. It will be bored to 20 mm. Now boring this hole to 20 mm. There will be a bushing inside this one, and it will be there with interference fit, so it should have at least quite exact dimension, but good surface finish doesn't make it worse either. Last 3 cuts will be done with lower feed to get a very good surface and accurate dimension. last cut. This should end up being exactly 20 millimeters in diameter. This dimension should be 21 millimeters. It's not that critical, but nevertheless I will make it accurate. I can get this dimension accurate by feeding in with the compound. Changing over to the collet system. First I clean up the chuck. I always do this before I take it away from the lathe. It's easier to do here, quite simply. And then, well, just unscrew it. And after it is a little bit loose, I have to hammer it because it's sitting quite tight in the taper. There you go. Now it's loose. And after that, just some gymnastics and cleaning everything quite well. It's important. Well, and now the collet adapter, and this one goes into the MOS 5 taper there in the spindle, and I always make it so that that hole is aligning with the notch inside this adapter. And then a little bit tapping, like that. And then, well, after that I will put this nut there. It is protecting the gears. Its actual use is to take off this adapter from the spindle when the time comes. Well, the backside needs also be cleaned, I noticed. And after that you put the drawbar in, and then we are going to use a collet of 20 millimeters. It is, well, it's this one. And well, it should also be cleaned. I have to wire brush it because, well, these seem to be collecting chips. So therefore I wire brush it, and also the groove there. Now it should go in quite easily. Well, of course, after lubricating it. And we are quite ready to start turning the mandrel. This material is chromoly, mock. And well, it's 20 millimeters in outer diameter. Well, first I will get rid of this nibble. Well, I'm using parting plate here. It's the best tool for getting rid of these thick nibbles. And then just to be sure, a little bit more in there. Then quite normal facing. I will do this because there will be a center at the end of this workpiece, this mandrel. It will hold the gear in between, and the other end will be in the collet, and the other end will be in a live center. So you can always put your work back to the lathe without doing any dialing. And now, well, here comes the center, and well, with this one I will make a center for the live center in this workpiece. It's a very simple operation, and although I made one mistake with this one, I was using too high speed here. You shouldn't do this, okay, for the thin part, but for the taper you cannot use that. Just listen how it starts to squeal. There you go. This is something that you should avoid. So what I do, I just turn down the speed, add some cutting oil there, and after that I will make a clean center out from this. Well, I tried to put the workpiece into this one, but it doesn't want to go there. Well, actually, I noticed there is burr, which I really need to get rid of before doing anything else. let's see if it, well, I know it will go there after this without difficulties. Oh yeah, there you go. Then I put it into the collet, and what I will do next, I will clean it up so that it doesn't have any oil or grease in it. No oil at all. And then I will put the workpiece there. It's really tight actually. And then use this Loctite 648 to glue it there. And after this has been cured, it really stays there. Here I am removing the excess material from the backside of this workpiece. Well, this also makes the gear to the correct width. And of course I will face this as I did with the other side. This one is not a functional surface, so this is quite purely cosmetic surface. Turning out the outer diameter of this gear plank. Well, our goal is 68 millimeters, and well, although this is not very critical, I try to make it quite precise. Well, let's see how I do this, but I can tell you it's really easy to do. Well, this time the gear will be 66 teeth, so the outer diameter will be 68 millimeters. And well, what I have done already here, I dialed in this piece here, set up the tailstock, also centered the cutter on the center line here. Okay. What has to be done is to set the cutting depth. Okay. Well, next thing was to decide, okay, 66 teeth. This means I found a disc which has 33 holes in it. So, well, with this hole, if you do some multiplication and divisions, etc., you end up being so that it will be 20 holes for each tooth. So I have set up my sector arms here, so that when I put them like that, that hole here under is now 20 holes from that point. You can count them if you want. Yeah, just stop the video and count if you want. And well, now what happens next is that I start milling this thing. And well, that's a very tedious process. So let's see now. I adjust the camera a little bit here so that you get a proper view of this operation. So first now I will adjust it, and well, the speed will be, well, 85 revolutions per minute, about that. And our feed is actually at the moment 17 millimeters per minute. So it's really slow. So let's set up this. Oh yeah, and what I did also, I will show that you before we set this up. This here. Oh, if you can. This is automatic stop. When this goes above there, it pushes this lever off. Can you see it? Yeah. It pushes it down and stops. It is set up now so that I don't rumble into my chuck. So again, now touching here now. Well, yeah. Oh, well, what is there to say? Just touch. And this is a little bit delicate operation. There you are, it's touching. So I locked the at the moment the Y direction, this direction, and now I zero my dials here. First of all, and then we go in 2.25 millimeters. So that was 1, that was 2, and 22. No. Yeah, 20 and 5 is there. Okay. Locked. I locked the answer. And then when I need to wait for the feed to warm up a little bit. This is the oil is a little bit stiff there. So I again use the cutter in view. Yes, it is. I'm again using, well, it's a new bottle of Rocco. On top of the plate, this that's probably more than enough. And now, just go to town, so to say. A little bit more Rocco there now. At the moment, I would like to have. Probably now. Okay. There we go. The first gap for a tooth. Well, I can make me a note here when it starts cutting, so I can back it up to the correct place. There it started cutting, so a little bit more. No, less. More. Like that. Let's see, I will adjust it later a little bit. Because, well, it's not easy to look into the blade when it's safe to swap to the next gear. Well, yeah, there we go. Well, this is a lot softer material than the previous. I will increase the heat a little bit. Otherwise I will spend my all night here. Let's double it. Let's put 24 millimeters per minute. This is way softer than the other material. Let's see now if that's the 10. Oh, it might be. Let's see. I forgot to lock this. Oh. Man. Next piece doesn't make horrible sounds. Good. And now let's lock it. Oh man. Well, 66 chances to get it all wrong. Okay. There will be 66 teeth. I probably will also increase the speed even more, because this material is really soft compared to the previous. Maybe that much. So, I will come back when we are at almost ready with this one. So see you then. Okay, so now this is the last cut. Let's see. There is a way to. Well, of course, you can see if your cuts went wrong when you cut the last gap there. That might be a wrong place. But there is yet another way to estimate that. First of all, let's go to the next hole. It is there. Okay. Now, when I move these sector arms, we should the next hole should end up in the 0 point. Let's see what happens here. Yoo-hoo! It's correct. So this is just an additional check that I have managed to get this without any errors. Okay. And then what I if you saw me wiggling this, so I always take away the backslash before I put the brake on. Then I changed this lubrication to Rockall paste, so I didn't need to handle the bottle every time. Actually, it works really nice. And now this is the last cut, so let's cut it. There we go. Oh, one more thing. I increased the cutter speed. It's now 120 revolutions per minute. Yeah. And then I have also increased the feed to 31 millimeters per minute. Seems to work better that way. Okay. Let's cut and not bubble all the time. Let's go. That was the last cut. And now I just take a little bit farther here, stop the entire thing, and let's see how it looks when I turn it around. Very, very, very hairy. And of course, I forgot to push the record button when I did the haircut for the bigger gear. Now I'm doing the smaller one, and this is quite similar process, just measuring the correct width here so that we have enough stock, and then tighten the stock. This is a 3-jaws chuck, so I can dial it, but no dialing is actually needed here. The part becomes symmetric anyway. The reason I was using the 4-jaw chuck with the bigger part was because it doesn't fit in this one. So yeah, here I'm boring an exact 24 millimeter hole. It's a little bit smaller than 24 millimeters, so that there is an about 300ths of a millimeter interference fit between these two gears. And well, it is. I almost lost it there. You shouldn't try to push it in by force. So yeah. and then just turn the outer diameter to a suitable value, and after that you just part it off, and yeah, like this. And furthermore you make the mandrel. This is 24 millimeters, a little bit under. Decrease it, and then after decreasing, decrease the gear, of course, as well. And after that, you just glue it in place. And then you go to the milling machine. Okay, here I'm ready to go to the last gear, hopefully for a while. So this one is 34 teeth gear, and I'm using a disc with 17 holes in it. So this means that every tooth has to be 20 holes. So 17 plus 3, and I have set these sector arms 17 plus 3. Furthermore, the center height was already set because I did the last gear here with the same setup. And then we have now learned that the correct speed, or at least for that material, correct speed was 120 revolutions per minute. Well, but this is harder material, so I decrease the feed somewhat, because it was 31 or something like millimeters per minute. Now it's I'm using 20 first. Let's see how that goes. Where are my safety goggles? Oh, there. Found them. And then I have also set up, well, let's see how this works. This is now locked. For the first whole backslash is removed. I feed first by hand so I can feel how hard material this is. This is rather hard, actually. Yeah. You can definitely feel this is harder. This has to be fed really slowly. The speed is okay. Okay, let's go. Maybe we could increase the speed a little bit. Let's do 20 millimeters per minute. Well, okay. Now I believe this is now the last teeth. So, first of all, we have made quite a lot of chips there. Wow. And then what I do next, I will release the brake down back here, release it, then we go one around, and then the 3 holes more like that, and there you stop. Well, it seems not to be the last. This is the one before the last, but yeah. I put you there in a different angle and remove the backslash and let's mill this one. There is one more cut. Seeds. Okay, I will show you something here. So now while it's cutting like that, okay, it makes horrific sounds sometimes. The reason is that this is so eccentric, the cutter is really eccentric. And then When it now progresses slowly, like this, we have here, let me put this like that, we have here a stop, automatic stop. It pushes this thing here, pushes down this metal piece here, which then will release the feed. It happens quite soon, we can watch it to happen. Let's see. I always do things like this that so I can concentrate on the real stuff. So because this requires, you have to do this without errors. Well, there it stopped. And now it's not, I have to turn by hand a little bit more. And then when I roll it back, I have made it so that here you can see number 10. Then it's in the correct place. Well, I will now put this camera away a little bit because I need to do the things here. Okay, release the brake. One turn and 3 more. And now let's see. This sector arm should now go to like that. This means that the next hole would be our start hole. Okay. Then I just remove the backslash by trying to turn it. And this is now our last cut. Let's see how it goes. Smokes a little bit. Oh yeah, there you go. There you go. Doesn't remove a lot. It's well about 500ths of a millimeter, if that. It's a really small amount. I think we need to maybe feel 500ths more. See how it looks, so that all the teeth are having a shiny surface. Well, actually they do. Very nice. Very, very nice. Okay. This has a safe edge also, so I use that one. In order to break the Loctite bond, you need to warm up the workpiece quite a lot. I tried with a heat gun, electric heat gun, but it's not enough. You need to do this by butane torch. And well, after it has been warmed up, I just push the mandrel through it, and there you are. There you go. Oh, it's not totally loose. Yes, it is. Wow. Yeah. Well, next you put the smaller gear to the bigger gear, and there is an at the moment 200ths of a millimeter interference fit, and therefore this needs to be warmed quite hot. After that it should just drop in place. Okay, so this here is the insert I'm using at the moment. It's a Cermet insert, and this holder is some NTK. Oh well, I don't know what this is, but it works. It goes into 12 millimeter hole. That one, it's a good thing. I have here the carriage stop, and furthermore, if you have been wondering what the hell I'm doing with my dials, so here you can see that I still have 1.75 millimeters to go. Then we are at 16 millimeters. But of course, when I approach the 16 millimeters, this is going to bearing fit. I will actually ream the rest. So I leave something like 0.3 millimeters there, so then the reamer goes straight. And now we just do some boring here. And this was okay. Did I already do this? Yes, I did. So now next I'm taking 0.25 millimeter cuts here. So and I believe this doesn't need any oil, but you cannot run it just fast. Let's see. That's about the correct speed. No. I will slow it down. Now it's 600 it's to 100 RPM. Oh yeah. This material is well, it's case hardened shaft, really, and now this should be, it's exactly what I want. Not too tight, just a slip fit. Good. This really tries to grab. You have to be super careful here. Yeah. Okay. Okay. So let's push that bushing in. First I warm up this thing to some suitable temperature. Okay, starting to blow on the, so maybe it is there. So now let's put this in place here, and then I have here, oh man, that's also hot. Here wrapped the bushing, it was in the freezer, but I will use this cold spray to cool it even more down. that should do it. And now let's wipe away the excess ice from that. It should actually drop in. Yeah, it did. Yeah, there you are. 200ths of a millimeter shrink fit. And this was just plan B, so to say. Yeah, now it's already there. It's it's changing color actually. This was so warm. Yeah. So that's how you do it. Okay. So this is what we ended with. There is a very tight fit with the bronze bushing. It's about 200ths of a millimeter shrink fit. And the same applies to this smaller gear here. And it all seems to be really good. Let me show you. So this is the shaft that is going to be used. It's a case hardened 16 millimeter shaft, and it fits precisely there. There is no play in it. And of course there will be grilles, and but this should be very nice. Okay. So in the next episode of Finno-Ugric Machining we are going to do something different. In this time it's going to be a threading tool. Not the ordinary threading tool you might use in a lathe, but this time it will be a little bit bigger. The thread that should be produced is M125 times 1.5. So it's quite a big in diameter. And I have one idea how to do this, but this will be in the next episode of Finno-Ugric Machining. So, till then, see you!